Hello everybody, welcome to computerhandle.com. So in the previous lecture, we had recalled what count-based loops are, alright? And how do we perform counting? And how do we really have to use the condition of counting to ensure and set a predefined value of how many times the loop has to be repeated. It is a condition still, but why we call it a count-based loop? It's because that we are counting the number of times the loop is being repeated, and we have to set it to a specific number. Alright, the loop has to repeat. It cannot go beyond than that. Alright, and that is because we know the loops are recurring depending on the value of x, on the count of x in this scenario. That's why we call it count-based loops. But if I were to set another condition instead of this, alright, well, if I were to set another condition, then this means that is not a count-based loop, that is a condition-based loop. We don't really care how many times it's repeated, but the only thing we care is that the process or the condition should be true, no matter what happens. Alright, and same scenario for here. This was a count-based loop, and we had done a trace table right here. Alright, but today we'll look at the condition-based loop, and instead of the counting condition, we'll have some else condition today. Alright, so that is what the basics of condition-based loops are. Now there are two types of condition-based loops you have to remember. The first one is preconditioned loop, and the second one is post-conditioned. Now you may recall, and you might be thinking, what do we mean by preconditioned and a post-conditioned loop? Well, it really depends on what you define yourself as process of the flowchart. Alright, so let's assume that here we have our multiple processes. Alright, but before the processes need to happen, we have our condition right here, and the condition will define the process, alright, whatever the processes are, and will bring back here. Alright, and if the condition is, for example, true after certain times the loop has been repeated, it's gonna go through the ending process, and then it's gonna eventually end. Alright, the thing you need to keep note here is that the diamond, the if-else statement, is before any of the required processes. Alright, if the process is already true prior to a cycle, it will just go here and the loop won't be repeated even one time. But if I were to draw another flowchart with randomized processes, but this time we have the condition diamond at the end. Alright, and if it says no, for example, we'll say here. If it says yes, we'll have the outputting process or whatever that be, and then we have the end. Alright, the difference between this and this is that we have the condition before any of the main processes that we need to perform in the loop, which means that if the process is already true, it won't even perform the loop a single time. Alright, but in this scenario, here, if the process is already true, no doubt that the loop will perform not even a single time, but the processes will perform at least one single time. So the feature of the post-condition loop, and this is the way we actually design both of these. So the feature of the post-condition loop is it's going to repeat itself. Repeat the main processes at least once, no matter what the case is. Alright, I'm going to write at least once. But here in this scenario, it really depends on the condition. We can even go straight from this path to this path without even coming to the loop, and therefore bypassing the processes. But here it is a compulsion, of course, for us to, obey and do the processes, and perform the processes before we even come to the condition. And it's often, very, very useful in some scenarios. And of course, we speak of scenarios. Let's have a look at some of the examples. Alright, so let's have a look at an example for each one of these. a precondition loop and a post-condition loop, starting with the precondition loop. All right. So this time our question is that we need to input integers till a -1 is inputted. So our condition will be, let's suppose that the input, the name of the variable we input is x. All right. So our condition will look more like, is x equals to -1? If it's no, it's gonna repeat the cycle. If it's yes, it's gonna output the sum of integers and it's gonna, end the program. All right. So let's have a look here. So first things first. We don't need the counting procedure here. All right, because there's no mention in the question of how many times we need to take note of the loop which is to be repeated. But we need to total. So similar procedure we use in the for loop right here. The total will be initialized to 0. Then the number we input will be added to the t to get the new value of total. And the value of, when we input the n next time, the old value of t, which will be, let's suppose 3, will add up to the new value of n, let's suppose it to be 5, to get the new value of t, which will be 8. We'll do a similar scenario what here. All right, so let's start designing our flowchart. So we'll hit start without further ado. Then we have to initialize all the variables to 0. And yes, let's first take note of what are the variables we need. So we need an input variable, input var, we'll let it know as x. All right, then we need to output the sum of integers, which means total. All right, total var, let it be t again. All right, and we have to take no note of counting, so there's no third variable, so these are the only two variables we need to take note of. So we have start, and we will initialize both of these to 0 in the process. Because it's process, we'll draw a rectangle. So t, and then we have the x initialized to 0 like so. All right. Then, because it's a precondition loop, we have a condition first before the main process. All right, and I'll tell you why later. So let's create a decision box, or shall I say decision diamond, and let's say, oh, we have a mistake, and the mistake we made is we forgot to input the value of x. All right, and this is what happens when I do stuff in a hurry. So always think before you write. All right. Now I'll abort this design and I will say such things here, input x, and now I'm going to return here to the diamond box. All right. So let's just discard this for permanently, and yeah, it's just nothingness. All right. So we've got input x. All right, we need to input the variable x, and now we have to check whether x is -1 or not. So we're going to write a condition as is x equals to a -1, a question mark. If it's a yes, we're going to end the program, and we're going to end it in this direction to save some space. All right, this is the yes arrow. So I'm going to say output t, which will be the total. And then I'm going to say end the program. All right. So here. So now, if it's no, we have to do the main procedure of counting the number. All right. And the counting will be pretty much similar to what we did here in the for loop. All right. So let's get started. And we have to input variable x. Then we have is x -1. All right. Then when x is no. All right, when it's no, then we're gonna say to total it plus x, like so. All right, and so we are totaling x, so the value of t is initially 0. We've input the value of x, let's say it to be 3. So our new value of t will be 3. All right, and then from here, we'll proceed back to the input part, like so. All right, and here's our messy flowchart completed. All right, and so let's drive in this thing now. So we say start, we have t initialized and x initialized to 0. Then we come here, input x. Now let's draw a trace table for it. Might as well, shall we? We have the values of x and value of t only this time. Alright. So let's suppose the value of x, our input first to be 2. Of course, t is initially 0, so it's going to add up to 2. It's going to go through the no part because x is not a negative 1. And then we're going to say, I'm going to come back here, I'm going to import x. This time let's input the value of x to be 3. Is x minus 1? No, x is not a negative 1. Alright, so we're going to head on to notepad. We're going to add a 3 to the previous 2 of total to get the new value of total, which will be 5. Alright, then we'll add another value of x, which will be, let's suppose, 5, and the new value of t again will be 10. Alright, and now let's suppose this time we add a value of 2 again. So we get the new value of 10 plus 2 to be 12. Now this time I input a value called minus 1. So the totaling won't occur again, because now it will proceed to ds path. And the latest value of t, which will be 12, is going to output that. Alright, this is going to be our final output for such data sets. Alright. And then after outputting t, it's going to end the program like so. And so this is an example for the preconditioned loop, like so. Alright. And notice why we are saying preconditioned, because before the main process, the climax of the flowchart, we have the condition first, more like what we showed you here. Alright. But for now, the post-condition loop, we'll have something like this. So let's have a look at that example as well. So our question is that we need to input integers till the sum of integers is 100. And then we need to output the number of times the loop has been completed. So the number of times loop has been completed, the first variable we're going to have first is counting variable. The condition won't be based on the counting variable, more like it was based here in the count based loop. We're still counting how many times the loop has been repeated, but the condition is not based on such. Alright, so I'm gonna say count var, let it be c. Alright, and then I'm gonna let's say the input variable as usual, let it be x. Input var, let it be x, and of course the total again, we're gonna have total var, total variable, let it be t. Alright, so this is key, and now time to draft our flowchart. So let's start the program first. Alright, and of course it's it's a oval. So let's get started. So first we have the main procedure. Alright, we have to first of all initialize each and every one of the variable to 0. Now to save some space, alright, here we did it in 2 little boxes, 2 little rectangles. To save some space, I can initialize multiple variables, multiple values in a single rectangle. Alright, so for example, I can initialize tc to 0, I can initialize x to 0, and I can also initialize t to 0, all in a one single rectangle, because all is, or you can say all are processes. Alright, and there's something which they had in common was the processes or the rectangle shapes. What I did, I combined all 3 into a single rectangle, and therefore I'll perform such procedure. Alright, now we have to input a number. Alright, we'll say input x, and because it's input x, we're gonna create a parallelogram on it, and I'm gonna move on. And now we're gonna add up the x to the value of t. Alright, more like what we did here. So alright, so we're gonna total like so. And then after the main process, alright, in the precondition loop we have the condition before the main process, but here we'll have the condition after the main process, right here. Alright, and a condition will be is t. Now in the past, what we have been doing is that because we know that it was only incremented by 1, we had c equal to 10 only. Here we know that x could only be minus 1 to terminate the program. Alright, so we know that it could be only minus 1, but here it could be 100 or more. All right, so t could be greater than equal to 100. So that's what we want to write. But in computers, we don't really have this symbol. So instead of this, what we write is this: greater than equals to. So is t greater than or equals to 100 will be the thing we're going to write here. Greater than equal to 100 and a question mark like so. All right, I'm going to write a line here, a divider, to make sure you don't get confused here. All right, so here's the condition. Now if the condition is true, if it's yes, we're going to say output t, which is going to be our total. All right, just in case, because this is not required, but we're doing it as an extra step. And the main thing that we have to do is we have to take note of how many times the loop has been repeated. So we'll output count c over c plus 1. All right, and we have to output c like so. All right, and then our program will end. Now when it's no, all right, when it's no, it's gonna come here and perform the counting process. All right, the loop has been repeated for one time. All right, and then it's gonna come back again after the initialization, before the main input, like so. And here is our main flow chart complete. Quite a neater one than the previous one, of course, but here's our flow chart complete. So we have start. Now let's drive in the program, and even let's create a trace table for it. So we have the value of x, the value of t, and the value of c. All right, and let's drive in this program. And I'm going to repeat myself. Driving a program means just running the program by your own chosen sample values. All right, so initially all three of them are 0. All right, then we're going to input x. Let's suppose we input the value, our usual first value of 2. All right, now the total was initially first 0, but it's going to add up to 2 to get the new value of total, which will be 2. So here we're going to write 2 here. And then is the total is greater than equal to 100? No. We're going to go to the no path. We're going to count the number of times the loop has been repeated. So we're going to put 1 here. All right, and going to come back here, and we're going to input x again. Now let's suppose I input the value of 10. All right, it's going to give us the new value of total, the old value of total 2, plus the new value of x, which will be 10, to get the new value of total, which will be 12. All right, and of course, if t is greater than equal to 100, no, we'll say go back, get the c incremented by 1, and input the value of x again. All right, now this time I'll just input a value of 5, and it's going to give us the new value of total, 12 plus 5, it's going to give us the value 17, and then again, no, it's going to give us 3, and then another x. This time, let's suppose we enter a massive value as an integer, and let's suppose we enter the value of 85. All right, so the new total will be now 102, and this time, is 102 greater than 100? Yes, this condition will be true now, because t is 102, and 102 is greater than or equals to 100. It's greater than, if it's 100, if the t was 100, never it meant the same thing. Then it's gonna go through the yes part. Now the main process was to just output c, but I just in case also output t to take note of what the total really is. All right, to let the user know or let us know what really the total is. So it's 102. All right, and then the number of main task for this question was to output the number of times loop has been repeated, and that is 3 for this scenario. So this will be our main answer for such a question. All right, and then our program is going to end. All right, so to repeat the entire structure of loops, we've got 3 different types of loops: count-based loops and condition-based loops, out of which one is preconditioned, one is post-conditioned. All right, here's the count-based loops we had a look in the previous lecture, and we even did an example and the trace tables. All right, and the condition actually was related to the counting. All right, it was related to to the way we were counting and incrementing the value of c every time the loop repeated itself. Alright, and then we had condition-based loops. And in condition-based loops, we have two multiple types of condition-based loop, one pre and one post. So in the pre, we have the condition first, then we have the main process, and then it's going to come back and see the condition first. But in here, we have the main processes first, then we have the condition. Alright, so it's different for multiple scenarios. But here, if you see that input integer is still a -1 was inputted. Alright, what if we input -1 in the first place? It's going to go here directly and it's going to output t, which was initialized to 0, and therefore it never was required to repeat the loop at least once. But here we needed to input integers till the sum of integers is 100. We could enter even 101 in the first try, but we need to input it at least once. Alright, we need to have the calculation, or you can say the main process is at least once before the condition, and that's why we had the post condition loop structure right here. Alright, and the main condition we're talking about is here. Alright, the totaling part, because when x will be 102, the value of t will be 102, and then it will go directly here. So it's a post conditioned loop, and this is a preconditioned loop, and these two are the examples for the post, completed examples for the post and preconditioned loop. Alright, thank you for this lecture.